Hi everybody and welcome to another lecture. I know, we're just plugging along here. So you guys are doing a really great job. I just wanted to remind you guys to keep up the good work as always. Go Dodgers. And, you know, hopefully you guys are doing well. You guys are learning a lot. You're enjoying these videos and you're really getting to know some of these different phylums and some of these specific organisms that we've been talking about. So let's just keep going. Let's just keep going along. Alright, so we are on the phylum Arthropoda today. So these guys are going to be your crabs, your lobsters, your shrimps, pretty much anything with an exoskeleton. And we're going to talk about what that means because it is different from a shell. So keep that in mind as we go along and we talk about some of these characteristics. Alright, so speaking of characteristics, this phylum is really big. There are a ton of things in the phylum Arthropoda. And that's because insects fall under this phylum as well. So think about every species of insects out there. There's a ton. Not to mention all the marine arthropods that are out there, which are also a ton. But specifically when it comes to the class Insecta, there are a ton of them. And so these are really relatives of insects. So you can think of like spiders and bees and wasps and all that kind of stuff. They're all related to things like crabs and shrimps and lobster. So, you know, next time you're eating a lobster, really you're kind of eating a bug. What? Yes, in fact, that's why they call them bugs. So if you've ever been actually lobster hunting, they call it, oh, did you get any bugs? It's because they are, yeah, bugs, essentially. I mean, obviously not, because they're not in they're in a different class. They're in Decapoda versus Insecta, but still, insects, right? Bugs. Okay. Now, we do have a lot of these different species. In fact, we have over 1 million, and a lot of them are going to be marine. So we have a ton of insect species, but we have a lot of these arthropods, these marine arthropods. And they are very, they come in a variety of different shapes and sizes, which we are going to talk about. Now, most of the largest group that we're going to be focusing on is crustacean, and it actually is the largest group. So class Crustacea, or not class Crustacea, but we're going to get to the taxonomy in just a second, but different than the class Insecta. Right, these are going to be your crustaceans. So these are pretty much all the marine organisms that you can think of when you think of the crabs and shrimps and lobster. In fact, that's all just under one order. That's the Decapoda. Let's see. We did talk about how arthropods are just super numerous. 75% of all the animals on the planet fall under this phylum. So you can easily say, what's the biggest phylum? Arthropoda. Right, by far, and like really by far, because not only in terms of diversity, but in just sheer volume, just numbers. So we're gonna talk about, I don't want to spoil it. Now, one thing that is really characteristic, remember I mentioned an exoskeleton, that is like number one. Okay, do they have an exoskeleton? It's gotta be an arthropod. Nobody else has an exoskeleton. Some organisms have shells, but nobody has an exoskeleton or outside skeleton. We have an endoskeleton, an internal skeleton, they have an exoskeleton. Okay, so if you open them up, all the squishy parts are inside, hard parts are on the outside. Now, this exoskeleton is made of chitin. So we've talked about silica, we've talked about calcium carbonate. This is a different type of hard material. This is chitin. Okay, C-H-I-T-I-N, chitin. Again, with that sound. Let's see, now, to grow, because we have an internal skeleton that actually grows as we develop. Right? When you're born as a baby, you have bones. Weird. And when you're an adult, you also have bones, but they just become much larger. Now, that's not how it works for these guys. So these guys actually grow by what's called ecdysis. Now, this is a word you definitely have to know. Ecdysis means to molt or molting. Okay, so think of like a snake kind of sheds its skin. Same kind of thing, same kind of concept. These guys actually produce a harder exoskeleton, right, on the outside, but on the inside, they have a softer exoskeleton that's still being developed. So you have the outside harder, it's been hardened by all the calcium that's in the water, strengthens that chitin, makes it nice and firm. So when the predators try to get at it, you can't get at it because, again, this is what it's used for. It's used for protection. So when you're growing, what you have on the outside is that hard exoskeleton, but on the inside you have a new layer, a new exoskeleton that hasn't hardened yet, hasn't absorbed that calcium from the water, it hasn't really gotten its strength just yet. Okay, so what happens is these guys will go through ecdysis or molting, and essentially what they do is they kind of shimmy out of their shell, so their exoskeleton. So they have their exoskeleton right here, and they kind of like shake it off and back out of it, and when they back out of it, you see an empty shell of an arthropod. So if you've ever been walking down the beach and you see all those little sand crabs and it looks like there's just dead bodies everywhere, those aren't dead bodies. None of those actually died. They're just molting. Okay, so they release out that extra exoskeleton that they have. Now they have a soft, squishy exoskeleton, and they're like, uh-oh, I molted so I can get bigger. Because really, when you molt, the exoskeleton on the inside is bigger than the one on the outside. So you're like, how can that even be? It's packed in because it's soft. It's still pliable. It's still flexible. You can still move it. And that's how they get out. I mean, they do this little wiggle thing and they back out. Right? They wouldn't be able to do that if the exoskeleton on the inside was hard. Okay, so what they do is they grow a larger one on the inside, and then when they actually back out of it, they're bigger in size. That's also how they regrow their claws and stuff, like if they're battling and they lose an arm, right? They just wait till the next time they molt, and then, ha-ha, the arm came back, yay! But they're vulnerable. As soon as they molt, they're vulnerable. So usually what they do is they go off and they hide for anywhere, about a week, sometimes less, sometimes more, mostly less. But basically they go out and they hide, waiting for that exoskeleton to harden, waiting for them to actually get that nice protective layer that they need. Now, if you've ever been to sushi and you've had soft shell crab, it's delicious, and you haven't, I absolutely highly recommend it. A little bit of ponzu, a little bit of lemon, oh my god, to die for. But a lot of people think that is a species of crab, the soft shelled crab. One, it's not a shell, it's an exoskeleton. But two, it's not. It's literally just a crab after it's gone through molting. So they have to get them at the right time, and then boom, they fry them real quick, and you can eat the whole exoskeleton because it's soft and pliable and it hasn't hardened yet. So my mouth is watering just thinking about soft shell crab. So if you guys haven't had it, totally try it. If you have had it, you know what I'm talking about, and it's delicious. All right, let's continue on. Let's see. Oh, another big one. They have jointed appendages, okay? Jointed appendages, meaning they can move, they can get up, they can walk around, they can do all this kind of stuff, okay? That's really important. We've learned about other organisms that aren't necessarily so motile, right? Sponges, cnidarians, they're the squishy squishies, right? The soft bodies, the clams, the octopuses, they don't have jointed appendages. This right here. This is a jointed appendage. It's connected in a joint with a hinge, right? It can actually move. This allows them really good motility, right? So they can actually move around really, really well. And this is going to be great for some of them, because some of them swim, right? It's really helpful if you actually have little legs that can swim. Now, most of these guys are divided into three parts: the head, the thorax, and the abdomen. The head, the thorax, and the abdomen. Kind of more condensed. We're going to see this in just a second. So if you're like, I don't have a thorax, so I can't really use me for this. But these guys do, and again, we're going to point them out in just a second. What else? Oh, they do have eyes, right? And they also have sensory organs. So this can be antennas, this can be a variety of different organs that they're using to kind of detect. Some have eye spots. They don't have great eyes, but they do have eye spots. They can detect against shadows. And again, the rest of them have eyes, and these like stalk eyes that kind of move around like that. Think insects, guys. What else? They do have gills. Shouldn't shock you. Most of these guys are going to have gills because the oxygen is in the water. How do you get the oxygen out of the water and into you? Gills. Lungs don't work so well for that. Try breathing underwater. I mean, don't. Please don't. You'll drown yourself. I didn't say that. And they have a variety of different feeding mechanisms. So some of them are scavengers, crawling along the bottom, eating dead bodies and stuff like that. Some of them are parasites that can actually kind of like, we're going to talk all about this, like bury into your gills and your mouth and all sorts of icky stuff. And some of them are going to be straight up carnivores. They are looking to eat you. They are going to go out there and try to actually hunt you. So we're going to talk about each one of those in better detail in just a second. But first, let's talk taxonomy. And you're already looking at this list going, what? Yes, I know, I'm so sorry, but we got to do it. Now, when we talked about mollusca, I kind of had you guys focus on the classes and the orders. And we're going to kind of follow that same pattern here, but there's going to be kind of a couple of exceptions, but they're really pretty easy. Okay, so we're in the phylum Arthropoda. We're in the subphylum Crustacea. That's kind of important, okay? The subphylum Crustacea. We have a couple different classes, the class Maxillopoda, the class MALACOSTRACA. In the Maxillopoda, so the class is Maxillopoda, the subclasses are Copepoda, these are the copepods, These are probably one of the most numerous organisms in the entire ocean. I mean, obviously diatoms are much smaller and therefore you can be more numerous, but copepods are just, there's so many copepods out there, guys. So think biomass, think copepods. The subclass Cirripedia, Cirrifoot, Featherfoot. These are going to be your barnacles. We're going to learn all about barnacles. I think I already told you some fun sex facts about barnacles. If not, I will repeat my joke because it's hilarious and a great trivia fact. The class MALACOSTRACA has a subclass of MALACOSTRACA, or the true Malacostracans, and that has the order Decapoda. This is pretty much your lobsters, your shrimps, pretty much anything that has 10 walking legs, hence Decapoda, 10 legs. The order Euphausia, these are the euphausids or the krill. Krill are another one. Euphausids, krill, they're really, really abundant in the ocean, and that's super important because, like copepods, they provide a ton of food for other organisms. So it's really important that we have these guys almost as like, not quite the base of the food level because these are going to be zooplankton, but they're eating the phytoplankton. And again, this is where all the energy comes from. So very, very important ecologically to have. Now the order Arthropoda is got the amphipods in them. So again, you know, the subclass Copepoda is the copepods. The amphipoda are the amphipods. The isopoda are the isopods. It's not really that hard as long as you kind of learn what they are. Then the order actually comes pretty simple. So we have the amphipods and the isopods. The isopods are definitely parasitic. Not all of them, but a lot of them. And they're gross. I got some really killer videos for you guys today. The subclass Hoplocarita is one that I included in there because it has one of my favorite organisms. Order Stompopoda, the mantis shrimp. So mantis shrimp, if you've never seen them, are total badasses. And they are like Mortal Kombat in the way that they will just kill their prey. It's insane. We're also going to see a video on that. All right, so just to simplify, instead of looking at that huge entire taxonomy list, we're just going to break it down into a little bit simpler sections. Subphylum Arthropoda, subphylum Crustacea, class Maxillopoda has 3 orders. Copepoda, Cirripedia, I'm getting way ahead of myself. Class Maxillopoda has 2 subclasses, the Copepoda and the Cirripedia, the copepods and the barnacles. So let's go ahead and get started there. Starting with the copepods, this is a very typical example of what the copepods look like. You can see 2 tentacles sticking off here, a couple little swimmerette legs, and a little telson right there, a little tail. We have basically some simple characteristics just to kind of help you distinguish them. These guys are very small. They're holoplanktonic or always planktonic. And they are, again, the most abundant, I'd say, animal in the world. I couldn't say organism because I think diatoms have it, surely for biomass. But again, the most abundant animal in the world, for sure, these copepods. Here we have a frontal view right here. We have a side view right here with, again, the tentacles hanging down. Very 2 classic examples of copepods. I do want you guys to be able to recognize the copepods because if it's the most abundant animal in the ocean, we gotta need to know what it looks like. And here's a very classic representation of it in drawing form. We have the single eye right here, right in the center. We have the 2 antennae coming off here. This would be the head, the thorax, and the abdomen. The head's kind of combined with the thorax. The cephalothorax, head thorax. What else? Here is it in color, apparently, because I added that for you guys. We have the legs on the bottom side here. Again, they're not really walking because they're planktonic, so they're going to be swimming. What else? Oh, this is also where they carry their eggs. A lot of these guys are actually going to show a little bit of parental care. So this is not like the broadcast spawning that we've seen before where everybody just kind of goes, hopes for the best. Right? These guys are actually going to lay their eggs and then they're going to hold on to them. So if you think about insects, kind of do this as well too. Like spiders will create that little egg sac so that they can burst out and terrorize you and terrify me. Oh, I walked into a bathroom one time when I was a kid. I didn't have my glasses on. And I'm looking around and I'm like, why are all these little spots everywhere? And then I look at the wall and it's just covered in spiders. I'm talking millions of spiders on like falling down here, coming along the sides. I went screaming out of that room as fast as I possibly could. If you can tell, spiders are my least favorite thing. Anyway, so just like some of these insects are actually going to show a little bit of parental care, or at least kind of put some kind of investment in it to like stash them somewhere safe or carry them with them in this guy's case. And we're going to see this a lot, especially with the marine organisms. They usually tend to carry their eggs with them. Now getting onto the subclass Cirripedia. Remember Cirripedia, these are the feather foots. So essentially what we have right here are the cirri. So each one of these tiny, tiny little lines right here that you can see are actually looking to do suspension feeding. Now, suspension feeding and filter feeding are different. Filter feeding, you have to suck up the water, take the food out, and release the water. These guys don't do that. These guys kind of go and grab the food and then pull it towards your mouth, like the ctenophores that we talked about and some of the jellies that we talked about, right? Suspension feeding. What's floating in the water, they're going to grab and pull towards their mouth. They are benthic and sessile, meaning they are on the bottom, found on the bottom, and sessile, stuck there, okay? Now, these guys sometimes can be xenoplanktonic. Remember, accidentally found in the planktonic, because barnacles sometimes get attached to whales, like we talked about when it talks about commensalism. So remember that xenoplanktonic word. Barnacles do fall into that. They do live inside their little chitin or cement housing, and that's what you can see right here. So these essentially are little plates that they're building, and the organism lives inside of that. So this would be part of his hardened exoskeleton made out of chitin, and it's basically their little houses. So they kind of look like little volcanoes, right, with a hole on the top. Different from limpets, different from chitins, right? The limpets look like little volcanoes with no holes. The barnacles look like little volcanoes, I can't do it, with a hole. And you'll see their little like trapdoors shut. And that's actually them in there with their little trapdoor shut. Fun fact about these guys, if I haven't already told you this joke, who is the world's largest penis relative to body size? Barnacle, right? Because these guys are sessile, they are stuck, they need to reproduce. And what if your nearest neighbor is all the way over there and you're like, oh, what do I do? Well, you send your penis, because you're a hermaphrodite, you send your penis up and out the door and around the corner over to your neighbor's house, right? Meanwhile, he's sending his penis up and around the corner and over to your house, right? So he's fertilizing you and you're fertilizing him, or he's fertilizing her and they're hermaphrodites, okay? They're both. Right? See, largest penis in the world relative to body size. Obviously, it's not bigger than a whale's, but compared to its body size, pretty sure that whale's penis doesn't go 3 or 4 lengths its body. Could you imagine that? That would be terrifying. Especially for the female. Oh my God. Anyway, all right. I digress. So here's what the inside of the barnacle looks like. Okay, so this is going to be that outer cement housing right here. We have our inner mantle going here. We have a cement gland, different than a shell gland. Okay, this is actually going to help them cement all the way down here to the rocks as well, because you don't want to get knocked off your rock, then you're not going to be able to survive. We have, what is it? We have this guy right here. This is his penis, which he will be able to extend outwards if need be. These are the cirri, again used for the suspension feeding. This is her oviduct and his penis. We have a stomach on the inside, all that good kind of stuff right there. This is a gooseneck barnacle. We actually have these off our coast. Very common. We have acorn barnacles, we have gooseneck barnacles. What you can't see is these guys actually have a longer stalk, so they kind of sit on the stalk here, and then the barnacle part's up here, and then the cirri comes out way up top here. These are some common barnacles that we also have. And again, this is what I was talking about, that little trap door that's shut. If it's empty, and I don't see any empty ones here, maybe that one, then it's dead and there's just this amount of housing that's left. But, like, these are empty here, right here. But these are all, if you see that little line, those are trapdoor. And so when the tide is out and he's not exposed to the water, because he's not going to suspension feed the air, there's no food there, right? But what happens, so he's going to shut the doors when it's hot and he's being exposed to the air. But then when the tide comes back out, or back in, he's going to be able to open those doors and then stick out that cirri and be able to feed. And here's our xenopelagic barnacles right here. And again, you can see them covered on the whale right here. And again, this is the reason that this is not commensalism, because pretty sure that whale does not like the fact that he's covered in little cement rocks. Right? Barnacles don't mind. Barnacles are like, yay! We get taken all over the world, and now we get to eat lots of food because we're, being exposed to lots of water. Moving right along to the class MALACOSTRACA. Okay, so now we're still in the subphylum Crustacea, but now we're in the class MALACOSTRACA. Okay, the subclass is MALACOSTRACA. Don't worry about the subclass. But these are the orders that you will need to know. So these are the important orders under the class MALACOSTRACA. Now, these guys do have a definitive head, not a cephalothorax, right? The head thorax. They have a distinct head region, the thorax and the abdomen. Now, we're going to start with the decapods first. Decapods, again, means 10 legs. In this case, it's 5 pairs of walking legs for a total of 10 walking legs. Now, they do also have a bunch of sensory organs, like we kind of talked about already, but these are going to be specifically his antennas. Sometimes they have 1 or 2 sets of antennas. They do have chilipeds or pinchers, right? These are the grabbing claws. And they do have pleopods, or what's called swimmerets. So some of these guys are going to be what's considered natant decapods, and natant means to swim. So in that case, their walking legs would actually be modified into swimmerets or pleopods. These guys pleopods are not only great for swimming, but they're also great for holding on to the babies, right? As you have those eggs, the female will hold on to them, keep them tucked under her, and then that's what she does for protection. Now, when you're crabbing or lobstering, it is illegal to take one of these guys if it does have eggs. It's known as being gravid with eggs. So you will have to pick up the octopus. Where did I get octopus from? You will have to pick up the lobster and then look underneath it. And if it has a big red thing of eggs, then you got to put it back. Totally illegal. Don't poach. And I know I've been lobstering lots of times before, and you just like see one and you're like, oh. And don't be that jerk that knocks them away and then takes them, because you just killed hundreds of potential babies. So again, the whole point is taking these things sustainably so that we can take them again later. If you take them all now, there's not going to be anything to take later. They're not going to be able to reproduce. So the whole point is that you take them sustainably so that they can reproduce later, because, you know, there's adults out there to reproduce. Taking a look at the morphology of the lobster, we can see the 2 chilipeds, or the 2 claws right here. We've got the walking legs, or also known as periopods, if you want to consider that. We have the pleopods in the back, so sometimes the walking legs are different than the swimmerets. Sometimes they're all modified. It really depends on the species that you're talking about. And again, these decapods do include the lobsters, the shrimps. So again, we can't just say, oh, they're all this, because again, it really depends species specific. We have the uropod connected to the telson right here. Again, that's going to be their tail. These guys actually have a really super powerful tail. And that's kind of their escape mechanism. So if a predator is coming at them and they can't, you know, deter them with their claws, going, get away, get away, get away, get away. Because, by the way, not all lobsters have claws. California spiny lobster off here does not have claws. So if those claws aren't going to do it for you, or you don't have them, all you got to do is give a quick flick of your tail and you just go, and these guys are gone in the opposite direction. Of course, people are a little bit smarter than animals, and all you have to do if you are lobstering is you put the net behind them and then you scare them from the front. They just go right into your net. Oh, that's pretty fun. Let's see, on the inside we have a mouth down here located, because they're usually, and then these guys are, a lot of the times, kind of just scavengers. They're just kind of scavenging what's on the bottom, making them kind of like cockroaches. In fact, these guys used to be considered the cockroaches of the sea. And you're like, well, that's wonderful. Also, back in the day, lobster used to be prison food, because only prisoners would eat it, because they were bottom dwellers. And that was like super gross to everyone else. But then we fished out everything in the ocean and we had nothing else to eat, and therefore we decided that this is now a delicacy. I know. It's called prey switching, actually. We've fished out one prey, so now we go to the other. And that actually happens with a lot. Like cod. You don't hear a lot about cod anymore. That's because we killed them all. Not all of them, obviously. There's a still small population of cod left. But same kind of thing. We started taking all the good stuff to the point where all that's left was things that 100 years ago people rejected as ew and gross. And now you pay $100 to go have a nice fancy lobster dinner. I know, just crazy. Talking about a different decapod, these are our crabs. Remember, crabs, shrimps, and lobsters, all part of the decapods. Count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You've got the 10 walking legs here. This one, these kind of have a paddle-like back leg. This is used for swimming. If you've ever seen a crab try to swim, they're not super good at it. But they are absolutely capable of doing so. This right here is known as the carapace. I don't know if I showed you that on... Yeah, this would be the carapace right here, basically from here to here. And this carapace would be, again, right here. This is actually how you measure how big they are. So when you're trying to determine, is it large enough to take, usually you measure the carapace right here. I think in a crab, you go wide, and in a lobster, you go long ways. I know in a lobster, for sure, you go long ways, and it has to be over a certain distance. Doesn't matter how big his tail is. Got to measure the carapace right there. What else? Looking at the underneath of him, right? These guys do not have a tail, like we saw in the lobsters and the shrimp. Imagine what happened is they kind of tuck their tail up and underneath, and now what we get is this lower abdomen section. Now, if I was looking at this guy, excuse me, girl, I could tell you it's a female because her Basically, this little abdomen part that tucks under is very wide. Now, this is important for females because this is where they're going to carry their eggs. In a male, not necessary. Okay, so his actually is very, very narrow, almost like a point or spear, and the female's is actually going to be pretty wide. We're going to see that in just a second. Now, unlike these broadcast spawners, we have actual parental involvement here when it comes to reproduction. So the males will actually directly transfer the sperm to the female. Again, that's what his little point is. It's covering his little reproductive organs. Okay, so he will actually transfer that directly to the female, so to ensure all of her eggs are fertilized. Okay, and that's another kind of parental care kind of thing. He's making sure that he's not just and walking away. Maybe they do get fertilized, maybe they don't. He's making sure, no, those are all fertilized eggs. Now, are they all going to survive? Probably not all of them. Again, they're not having in the millions, but maybe in the hundreds, maybe in the 50s, right? Still a lot. And so chances are some of them are still going to survive. In this case, probably more than not, especially in the millions cases. Now, sometimes the female actually will house these eggs for extended periods of time until they are fully ready to develop. Sometimes they won't, they'll just kind of leave them. But a lot of times they will carry them, again, tucked up underneath. Now, females also are kind of, miraculous in what they are capable of sometimes. We're pretty great. But one thing that we can do, well, they can do, not us, because this would be weird, is if conditions aren't necessarily right, meaning they've mated, but maybe she's a little starved or the water's too warm or just something's not right, she will actually store that sperm. And I think that's something we've talked about before. She'll store it until conditions are good. So she's like, yep, I'm fertilized. Yeah, no, I'm not having eggs yet. I'm not having babies yet. So imagine you do your reproductive act and then 6 months later you're like, okay, now I'm pregnant. Like, whoa, that's not how that works. You can't just turn it on like that. These guys can. Kind of funny. Another really cool thing that these guys do are mating rituals. So I do have a video to show you guys about these mating rituals, and they're pretty awesome. Usually what it is males battling over the female. So the female gets her choice. Who's she going to mate with? Oh, it depends. Why don't you guys battle it out? Who's ever the biggest and the strongest will win, and then I will mate with him because he must have the best genes. Female's choice, ladies. Female choice. So that's what I'm going to show you guys right here. We're going to check out some fiddler crabs. Remember I talked about males and females? So we're going to look at the difference between the female and the male. In this case, these are blue crabs. They're also sexually dimorphic, meaning there are two sexes. You can very clearly tell that he's got bigger claws, she's got smaller with red tips. This is kind of how they identify each other. Obviously, she's a smaller female, he's a larger male with these larger claws that he's going to battle another male for. The whole point is to battle, to be able to reproduce with said female so that your genes will actually move on and you will be successfully reproductively successful. There it is. Now, here's what the eggs look like. Remember, they do have that bright orange, bright red color, so we can see a lobster. Now, this is probably in the millions here. These are some small, tiny eggs. Really depends on the species, but those are a lot of eggs. But they're all fertilized, unlike the broadcast spawners where females release, males release, right? These guys have been directly fertilized, so already gives them a higher chance of survival, right? Just like insects, insects, there's a lot of insects, and they reproduce like crazy, and they have a lot of babies. Same kind of thing here, okay? Luckily, they're more likely to survive if they are, again, pre-fertilized. So quiz! Is this a male or a female? Well, it's not very wide. Kind of looks skinny and narrow. If you said male, you are correct. What about this one? This one's a female for sure. You can see huge. Look at the difference between the two. Male, female, right? Big, big difference. Nice and wide. What about this one? This is a trick question. It's a hermaphrodite. It's actually both. So every once in a while, even though there are females and males, every once in a while you'll kind of get one with both. And that's what you can see right here. In fact, this actually guy is split down the middle. So this is nice and wide, like a female. This is nice and skinny, like a male. In this case, it is a hermaphrodite. They're not usually hermaphrodites. They are two sexes, right? But in this case, this guy happens to be a hermaphrodite. I was once doing a pig dissection, and a student was very confused on the sex, and I was like, He goes, well, what's this? And I was like, well, that's an ovary. And he goes, well, then what's this? I was like, well, that's a testy. Oh, yeah. It did have both. On one side it was a male, on the other side it was a female. So it does happen every once in a while. Now, I did mention natant before. So the word natant means swimming, right? So the natant decapods are your swimmers. A lot of shrimps can swim. I mean, even the crabs and the lobsters can swim. Not always very well. Typically, when we think of the natant ones, usually we're thinking about, like, they're always swimming. But again, it does include the lobsters and the crabs, ones that are still able to swim. Now, this is a pelagic red crab. It is called a pelagic red crab because it is, pelagic, meaning this guy is always found in the open ocean. And during the summer months, you can see them blooming like crazy. Like, you shine a flashlight down, and it's just all these little red specks shooting all over the place. It's crazy, but pretty cool. And again, we have some deeper water shrimp right here. These guys are pretty much all pelagic as well, just kind of swimming around in the open ocean. A lot of mysids. Oh, we haven't talked about mysids yet, but we are going to talk about mysids. They do the same kind of thing. All right, so moving right along, here's a couple of the other groups that we're going to be talking about. And I just kind of showed you this to kind of give you an idea of what they look like. So we're going to be talking about the euphausids or the krills. I don't think we actually talk about ostracods in this one. These guys are really cool. We are going to be talking about the amphipod. That's the guy living inside this barrel. This barrel is a salp, and we haven't talked about those yet, but we will. But this guy right here is actually living inside of this. One of the inspirations for the movie Alien, by the way. And this is our copepod, a side angle of our copepod. So they are very different, even though they're all, when you look at them, you're like, I don't know, they're all kind of shrimp-like, but really when you look at them in their actual body morphology, they are pretty different. So make sure you can at least distinguish between them. All right, let's talk about the krill. Euphausia. There it is. Euphausia. I can't even say it anymore. I used to know how to pronounce this word. Apparently it's been a minute since I've said it. Obviously, this is kind of a hard one to say, let alone spell. Just be able to recognize some of these orders. I mean, like Decapoda, yeah, I'd have you spell that one. But Euphausia, I probably wouldn't have you guys that one. These guys do have pleopods for swimming, and that's because they are holoplanktonic. Remember, always in the plankton, right? Always at the mercy of the current, so always going to be found pelagically or in that water column floating around. They do have their thoracic legs are actually modified into what's called a feeding basket. So kind of easy to identify them because it almost looks like they have this like fluffy little feathers around their legs, basically right at their kind of thorax area. And we should see that right here. Okay, so these are going to be the feeding legs. This is basically their feeding basket. So it's almost like they're swimming around, just kind of like, again, suspension feeding, grabbing what's out of the water and then pulling it towards their mouth to be able to eat it. The gills are going to be located here externally, and which is really great for them because they're constantly just swimming around in the water. They can pull whatever oxygen out they need. These are the pleopods right here. They're modified, so again, not the walking legs, right? Well, actually, these would be considered the walking legs, the 10 pair of walking legs. These would still be the pleopods. So in this case, they do have both. They also have a straight angle. When we look at shrimp, we're actually going to see that they have a 90-degree angle in their tail. These guys usually have a straight angle in their tail. Oh, and they do have what's called photophores, which are these little light organs that actually can produce light if they need to. This is a form of communication, a form of sometimes predator avoidance, sometimes mating. Many uses for these photophores. So here's some classic examples of some euphausids. We have, again, the feeding basket, the fluffy legs up here, fluffy legs up here. Really easy to tell the difference between the two. Straight angle in the tail, not that 90-degree tail bend. And you can see right here, very important and abundant food source, and this is a bait ball right here. So essentially this is millions or billions, I'm not sure, but a ton of these euphausids right here. So very important food source. Moving on to the amphipods, these guys are pretty cool. These guys are deep water, usually have this kind of transparent exoskeleton, so not as resilient as, say, like a land crab that would actually have, a hard exoskeleton, but still used for protection, kind of like their structure and support system. These guys are going to be very deep water. They usually have a very large eye and a large head. Like I said, some of them are completely transparent because if you're in deep water, transparent is good. You're essentially completely invisible because there's no light down below. And some of these guys are parasitic. I don't think I actually have a video of any of these parasitic ones, but so you can see right here, this is this giant head. This is that giant eye section right here. This is the only good one I could find who doesn't actually have the big head. But it's just a kind of, you know, showing you guys an example of the difference between the antenna, the walking legs, the pleopods, and the uropods. That's all. Here I did have a parasitic one. Okay, so these are the amphipods. This actually is one of the inspirations for the movie Alien. So if you look at it, I mean, look at this head right here. The head, the double eyes, living inside of another organism, having its babies, and those babies bursting out and just... Yeah, that's exactly what these guys do. So this is a salp right here. This barrel-looking organism is a salp, and we're going to learn about salps in another lecture. But this guy actually lives inside of a salp and uses the salp for protection. So even though he has his own exoskeleton, remember, it's not a super great one, so he lives inside another organism to let the other organism get injured or beaten up or eaten or whatever. And also, he lays his eggs on the inside, and when they hatch, they eat the salp from the inside out, hence the aliens. Yeah, you'd actually be shocked at how many horror movies are based on not only marine organisms, but just organisms in general. All right, the order Isopoda. Okay, so these are the isopods. These guys are the little creepy crawlies that actually can infest your gills and your body and your tissue and just are super gross. Oh, I'm going to show you guys a video that hopefully won't make you gag, but it makes me gag every time. So gross. Anyway, these guys are flattened and highly segmented, and you can see that right here. It almost looks like a little roly-poly. In fact, you can think of these guys as the nasty, weird parasitic cousin of a roly-poly. These guys have no chelipeds, no little pinchers, but they do have hooked periopods, so their walking legs are actually hooks, because when they do crawl inside you, they hook onto you, and then there's no getting them off. And especially if you're a fish, well, you don't have hands. What do? Pull it off? No, not possible. So with that said, let's gross you out a little bit. So here we have two giant isopods living on the cheeks of a fish. Again, fish don't have hands. You can't just knock them off. So you can see these guys are almost the size of his entire head, and he's got two of them. Just very nasty, very bad for you. This is what those cleaner shrimp were actually trying to pick off. Things like ectoparasites, like these isopods. Here's a couple of them living on the inside. So this fish was caught. He was brought out of water, and these guys said, hey, fish is dying, I'm out of here. So then they just start crawling out of the mouth, and you can see just bugs just crawling out of their mouths. Like I said, super creepy. And this is probably the grossest one. This is a tongue-replacing isopod that actually cuts off the circulation to the fish's tongue. The tongue falls off, and he crawls in there and pretends to be the tongue. So gross. Let's take a look, shall we? I got some videos for you guys. You're gonna love them. Well, I hope you really enjoyed those creepy crawly videos because they're... Ugh. Anyway, so you'll never forget the isopod, hopefully, because it's just so parasitic and gross. Oh, and by the way, deep sea, they get really big. Yeah, that's his hand. That's his hand. That would be like life size, like right here. Can you imagine this? And he's trying to like, ugh. No thank you. Look at that little creepy guy. He's got an evil little eye right there. Look at this. Nope. Pass. All right, guys, last but not least, let's talk about the subclass Hoplochorida. These guys are the mantis shrimp. So very cool. In the order Stomatopoda. These guys are not only super cool to look at, I mean, look how bright and colorful he is, but these guys, like I said, are total martial arts badasses, and they will punch your lights out, no joke. So we are going to do a really great and funny true facts video on these. But let's just talk about them a little bit more before I do show you guys those. So these guys are extremely aggressive. When I'm saying Mortal Kombat finishing moves, I mean they really are Mortal Kombat finishing moves because this guy is crazy. They're extremely solitary because, again, they'll probably kill anybody who they're roomed with. They actually have some video of stuff of these guys in aquariums, and they're just beating everybody up in that aquarium. So you probably don't want to keep them with anybody else in your aquarium. They usually do bury themselves, so they usually hide in either rocks or small little holes in the sand, and they will pop out and they'll basically grab their food and then they'll hide back in their little holes. So that's kind of what they're used for protection and ambushing their predators or their prey, obviously. They do have very specialized structures. So there are two different types of mantis shrimps. One that has kind of bowling ball hands and that they're just going to punch you. And the other one has these like spears, hence mantis. So if you think of like a mantis's claw that has that like spear, it's the same kind of structure, hence mantis shrimp. And just like the mantis, these guys are predators and are trying to kill you probably. I mean, not you obviously, but trying to kill any other marine organism. So let's just take a look. Oh, and they have really, really advanced eyes. In fact, they can see in 9 different color spectrums. We can't. So imagine 9 different colors that you couldn't even possibly imagine. That's what they can see in, which is probably why they are just so crazy brightly colored. We're going to say a video on that. I don't want to spoil the jokes. All right, so let's take a look at the video. Once again, those true facts videos are just my favorites. So hopefully you really enjoyed that one. Total little badass, and he's the story of the hermit crab, and I love it. I love it. Anyway, so again, we can see the bowling ball hands right here. These are the basher ones that are actually used for the smashing, and then right here and right here we can actually see the grabbing or the mantis spears, and that's either for spearing or the grabbing and then pulling in. And that's what, unfortunately, this little clownfish is getting the brunt end of the deal here, because he has now come out, and look at the reach on that guy. You don't have to be close for him to actually be able to get you. So mantis shrimp, guys, super cool. Also have been known to break glass in aquariums. That's what, if you've ever been to an aquarium and you see a mantis shrimp exhibit, what they always say is no flash photography, no flashlights, no nothing. Because their eyes are so sensitive to the light, they will break the tank, and they have and will do it again. So again, very hard to keep in captivity because they usually end up breaking through the tank, which is not good. And with that, guys, that's all I have for you guys today. He was a little shellfish because this is a shellfish. I know. Terrible dad jokes. But I always like to leave you guys with a little smile, hopefully. So thank you so much for sticking with me. We are almost done with the invertebrates, guys. We have one more phylum to go. Phylum Echinodermata is next. And then we are done with the invertebrates. So then we're actually going to be talking about vertebrate animals next. So we have a lot more phylums to go through, and it's going to be a ton of fun. So stick with me, and I'll see you guys next week.